Hi everybody, in this video we are going to discuss about how to perform insert at a given position in a circular linked list. So the input for this algorithm will be the list in which we are going to insert, the position at which we are going to insert, and the data what we are going to insert, right? So let us consider a circular linked list. If there are 5 nodes like this, and if you want to insert value 17 at the position 3, then you want the resultant list to contain 6 elements, and it should be in the order 10, 7, 17, 15, 28 and 19. This is what is expected. The one exception that we have to consider while discussing about insert at a given position is if position is equal to 1. If the given position is 1, it is better to call the insert beginning function itself and we can return whatever that particular function returns. If the position is not equal to 1, then we can have a temporary pointer, make it to point to the first node of the linked list, and you can have a counter and initialize the counter to have a value of 1, right? So your counter will be 1, and then what you have to do is you have to move your temp to the node which is at position 1 position less than POS, right? So if you want to do the insertion at position 3, then move your temp to point to the node at position 2. That is what is we have to do. But one thing that we have to consider is if the position is not valid, right? If the position is not valid, for example, if there are 5 nodes as shown here, and if the position is 7, then this is not valid. Actually, when you have 5 nodes, positions that are valid are from 1 to 6 only. It cannot be greater than 6. If I give the value as 7, then it is the invalid position. That should be rightly handled. So how we are going to do is we will initialize the temporary pointer to first node and counter to 1, and then we will be checking actually whether we are in the last node. If you are in the last node, then you will come out, right? Come out of the loop. You will not proceed. You will come out of the loop and check if the condition is satisfied. That is, if your temp is at the proper position, right? By using the counter, we can check that if the value of counter is 1 less than the position, then we can conclude that we are at the right thing, right? So you will be having a condition check whether your temp is not the last node. If your counter is not equal to position minus 1, then you are going to move your temp to the next node and you will increment the counter, right? So let us run through the idea with the first case, position equal to 3. Okay, so when I want to do an insertion at position equal to 3, your temp is here and counter equal to 1, right? As discussed, you will be checking if your temp is at the last node, no. Then you check if your counter is 1 less than the position, no. Okay, in that case you have to move your temp to the next node and increment the counter. Now you check whether your temp is at the last node, no. And now you check whether your counter is less than 1 less than the position, yes. So you will stop here, your temp will be here, you will stop here, and you have to make the changes, right? What changes you have to make is you have to make the next part of the new node. This is the new node, right? You have to make the next part of the new node to contain the value which is in the next part of the temp, right? So what will happen here is this connection will be made, right? This connection will be made, and then you have to make the next part of the temp equal to new node. So when I tell like that, this connection will be made. Okay, so this node will completely come inside the linked list. This will come as the third node. Okay, now let us consider the case when I give the position as 6. What will happen if I give the position as 6? So if you start the algorithm fresh, then your temp will be here, right? Your temp is here and your counter is 1, right? As per the algorithm, your temp is not in the last node. So you have to check whether your counter is equal to 1 less than the position. No, counter is 1, position is 6, right? So you have to move the temp to the next node and you will increment the counter. Now check whether temp is at the last node, no, and you check whether counter is 1 less than the position, no. So you move the temp to the next node and you will make counter equal to 3. Now you check whether your temp is in the last node, no, whether your counter is 1 less than the position, no, right? So increment the counter and move your temp to the next node, and now you check whether your temp is in the last node, no, whether your counter is 1 less than the position, no, increment it and move temp to the next node, right? Now you check whether your temp is in the last node, yes, right? So you will come out and check whether the value of counter is 1 less than the position. Yes, it is valid. Okay. So as per the algorithm, you have to make the changes. That is, the next part of the temp should be stored in the next part of the new node. So automatically the connection to the first node will be made, and then you will be making the next part of the temp equal to new node. So the connection between the last node and the new node will also be made, and this will become the new last node. That will be perfectly alright if the position is valid. Let us formally write the algorithm. So there are 3 inputs as discussed, and when position is equal to 1, you are going to call the insert beginning, right? Otherwise create a new node, and you are checking, for safety we are checking whether the node is properly created. So if it is not equal to null, right? And you are going to initialize the temp and the counter, and while temp is not in the last node, you are going to repeat step number 6 and 7. In 6 you check if the counter is position -1. Then you are going to break the loop, right? You are not going to further move, otherwise you have to increment the counter and you are going to move the temp to the next node, right? After coming out of the loop, you have to check whether the position is valid. When the position is valid is if the counter value is equal to position -1, then we can understand that the position is valid, right? So if the condition is satisfied, repeat step number 9 to 11. So in 9 you are making the connection between the next part of the new node equal to next part of the temp, and in step number 10 you are going to tell next part of temp is new node, and you will return true if this condition is satisfied, and if none of these conditions are satisfied, then we are going to return false. Okay, so now let us implement the code and see. So this is the declaration in the header file, insert position. We have to pass the address because we want to see the changes that are being made, and then the position where we have to insert and the data part, right? And this is the definition that we are going to make. So as per the algorithm, we are going to check if the list is empty, right? So call is empty with the list. If the list is empty, then we are going to call the insert beginning function and just return what it returns. Okay, so L comma data, right? If the list is not empty, then we have to create the node. So let us declare the required pointers here. Okay, temp. So now we can tell new node is equal to create node. You have to pass the data part because the node will be loaded with the data, and if new node is null, right? If new node is null, then we have to return false. Sorry, false is not available in C. Bool data type is not supported, so I am returning 0. Otherwise, what we are going to do, we are going to make temp equal to the head of the list, right? So L head, right? And you are going to have a counter also. I need a counter. So let us declare an integer variable, and let us here assign the value of 1, right? And while temp next not equal to head, right? Temp next not equal to head, we are going to just move to the next node, right? Also we are going to check if the counter position is 1, right? So if counter equal to position minus 1, then in this case we have to break, right? We have to break. Otherwise you are going to increment the counter and make temp to move to the next node, right? And you will come outside, right? This is what we will do inside the loop, right? And you will come out and check if the position is valid. How we can check the position is valid is if your counter is equal to position minus 1, then you can understand that the position is valid, right? So in that case, what we are going to do, we have to do two things. One is next part of the new node will be equal to temp next, right? Next part of the new node is equal to temp next, right? And next part of temp is new node, right? So temp next is equal to new node, okay? And you have to return true if this is properly done. Otherwise you come outside and return false. But we are writing a C code, so let us return 1 when we want to return true, and let us return 0 when we want to return false, okay? So hope the code is fine. Let us check it. So the main is already returned with the position. We are making a call when we want to insert at position 3 the value 10, okay? So let us check this. There is one warning, actually it's error. I made a mistake. When we are calling, we have to give insert underscore position. This is the way I have defined the function there, so I have to give it properly. So now there is no compilation errors. Let us run the code and check. Now we are seeing 3, 2, 1, 5 and 4, right? So we can write and see the values. So we are first inserting 1 at the beginning, right? And then 2 at the beginning, and then 5 at the end, right? And 3 in the beginning, okay? And we give insert position 3, 10, right? So we want the elements to be like this: 3, 2, 10, 1, 5. Let us see what is getting printed. 3, 2, 1, 5, 4, right? Okay, I have a difference, right? Maybe I made a mistake here. Insert beginning 1, right? And insert beginning 2. After that insert end 5, okay? And insert beginning 3 is being done, and insert end 4 is done, and insert at the given position 3, 10, right? So you have to have 3, 2, 10, 1, 5, 4. This is what is expected, but we see only the elements except 10. So let us check the code. Actually the code is correct. I made a mistake while I was doing compilation. I didn't recompile the file. That's the problem. So let us do it again. We have to compile the first file, which is containing the definition of the functions, right? So I do only compilation and I redirect the output to cll.o, and then I do compilation of the application file, and I am once again telling only compile, and I am redirecting the output to clla.o, and then link the files, both the files, link it using GCC now, right? And then you give a.out, right? So we can check whether the desired output is got or not. 3, 2, 10, 1, 5, 4. So we have got it. I'll be sharing the code in the GitHub. Thank you.